So you have completed the problem to finding out the short term as well as the long term deflection, but as I mentioned earlier, if in problem it is not also just find out the permissible deflection. So here you got the value of the deflection as positive, which is downward deflection, therefore find the permissible deflection. Downward deflection according to IS 1343 is span by 250. The span is mentioned as 8000 by 250, which is 32 mm. So this is the amount of maximum deflection which can be taken care by the PSC beam. Therefore this is safe. Which how much you got is 28.41. So here the maximum one is 32 mm. Therefore whatever the beam which will be designed for this will be safe in the design criteria. So this is how you are going to check. This is very important while doing the designing of the pre-stress beam. That's why I have just mentioned it here to calculate the how to check the permissible downward deflection. Okay, so this is 32 mm, which is safe in this problem, for this problem. So let's go to the next problem. A rectangular concrete beam of cross section 150 mm wide and 300 mm deep is simply supported over a span of 6 meters. So 6 meters it has been simply supported. It is pre-stressed by means of symmetric parabolic cable at the distance of 120 mm from the bottom fibers at a support section and at a distance of 60 mm from the bottom fibers at the mid-span section. Initial pre-stress in the cable is 300 kN. Determine the maximum deflection of the beam at transfer. So at transfer you have to find out central concentrated force to be applied to nullify the above deflection. So you have to apply a value of W force so that you can nullify the amount of deflection due to transfer. Take the unit weight of concrete as 25 kN per meter cube. So if it is given in the problem itself, you can take it as 25, otherwise you have to take it as 24. Modulus of elasticity of concrete is 3.8 into 10 to the power of 4 Newton per mm square. So this is what is given in the problem. So now if you look at this problem closely, so it is pre-stressed by means of symmetrical parabolic cable at a distance of 120 mm from the bottom fibers at the support and at a distance of 60 mm from the bottom fibers at the mid span. So here this point is very important. Remember, from here to here it is very important. Why? Here they have not directly given you the eccentricity, instead they have given you the cover from the bottom to the tendons. Remember, here there is no mention of eccentricity. Here they have given you the values of cover. So here, as I mentioned earlier, here from the bottom at the center span it is 60 mm, okay, and from the bottom to the support it is 120 mm. So if you have written it here, it has eccentricity, E1 has 120 mm and E2 has 60 mm, you will be totally wrong, and the neutral axis will be somewhere here. So this is a rectangular one and this total distance is 300. So the total depth is 300 mm. So therefore this is 300 mm. Therefore this value will be equal to 150 mm. Remember, this value will be equal to 150 mm. And the value of E1 will be equal to 30, because it is 150 minus 120. Therefore the E1 value will be 30. And what will be the value of E2? It will be equal to, how much will be the value of E2? It will be equal to 60 mm. Remember that it will also be equal to 60 mm. So how we are going to calculate that? It is 120 minus 60. So this value will be equal to 60 mm. Remember, E2 will be 60 and E1 will be 30. It is not directly given in the problem. You have to find out. This is very important. Here eccentricity is not given, where you need to find out the value of eccentricity. Therefore the value of P equal to 300, and in the problem itself they have given the value of P equal to 300 kilonewton. So here the major change is that how you take this consideration. If you do this itself wrong, the whole problem will be wrong. And what you need to find out, you need to find out the value of W, okay, in this problem. Now deflection due to dead load. So deflection due to dead load is B into D into density of concrete. Here in the problem itself it is given as 25, therefore it into 25. So you will get this much as the dead load due to the beam. Then deflection due to dead load equal to formula, which you have to remember, 5 by 384 into Wg into L to the power of 4 EC into Ix. So we haven't calculated the value of Ix, so calculate the value of Ix equal to BD cube by 12. So you will get the value of Ix as 337.5 into 10 to the power of 6 mm to the power of 4. So substituting all the value 5 into 1.125, which you have calculated here, into 6000, which is the span, divided by 384 into EC value 3.8 into 10 to the power of 5 and EX value 337.5 into 10 to the power of 6, you will get the deflection due to dead load as 1.48 mm, which is acting downward. Remember, use the symbols also. Next, deflection due to pre-stress. So eccentricity at the support, it is 300 minus, so here there is a important thing, eccentricity is 300 by 2, that is till you have to find the neutral axis, that is 150 minus 120, which will be 30 mm below the neutral axis. Important, it is below the neutral axis, below the neutral axis. So both the cases it is below the neutral axis. So in the diagram itself I have told you how to calculate this value. Just here it's a mention in the step by step procedure how to calculate the value of eccentricity. So at the mid span also E2 equal to 120 minus 60. So you will get the eccentricity value E1 and E2. Then draw the bending moment due to E1 and bending moment due to E2. Now here the major important part is that due to E1 also the bending moment is negative, not the positive. Due to that pre-stress with an eccentricity of E1, it will have a hogging effect on the beam, not the sagging effect, it will be a hogging effect. So therefore there is a negative sign, okay, otherwise it should have been positive. So here this is the major change in this problem. Here this is the major change where you will get up negative bending moment, and the other conditions are same. Here the bending moment due to P1 plus P2 will be again negative. Just substitute the value of P and then substitute the value of E1 and E2. So then to calculate the value of deflection due to pre-stress, area into x bar by EC into Ix. So I have taken this negative common outside. So this value will also be negative, this value also will be negative. Therefore I have taken that negative outside and written both as positive. I have directly taken this negative outside, 1 by 3.8 into 10 to the power of 4 into 337.5 into 10 to the power of 6. So these both values, I value I have calculated, EC value is given in the problem itself, 9 into 10 to the power of 6, the value of P into E1 into the length by 2, 3000 into length by 4, L by 4 value, which is the distance for X bar. Then for the parabolic cable, 2 by 3 into 3000 into 27 into 10 to the power of 6, which is P into E1 plus E2. So this is the value of area of the parabola, into 5 by 8 into 3000. So this is how you have to write instead of remembering the formula using this bending moment diagram. If you remember this, that P into E1 and P into E1 plus E2, this is enough, and check whether the E1 and E2 is above the neutral axis or below the neutral axis. On that basis this negative symbol comes into picture. So the deflection is upward now. So the value of delta is 11.05 mm, which is acting in the upward. So the bending of the beam will be due to pre-stress will be upward. It is 11.05 mm. Then, so the maximum deflection at the transfer is dead load plus pre-stress. Here the live load is not mentioned, so that is directly equal to dead load plus pre-stress. So 1.48, which is positive due to dead load, and 11.05 is negative. So therefore you will get a value of minus 9.57 mm. Then here you needed to find out this value of W, which will make sure that there won't be this deflection of 9.57. So it will be, the beam will be in equilibrium in a straight manner. To nullify the above deflection, what is load required? So the deflection due to central point load will be equal to, so this formula is for deflection due to central point load, delta live load, when there is a point load acting. So WL cube by 48 EC into Ix, which is, you have already found out 9.57 because they have told to nullify this much amount of deflection. So L cube is known, 48 EC is given in the problem, you have found out Ix. So substituting and calculating using our calci, you will get the value of W as 27.27 into 10 to the power of 3 Newton. So value of W equal to 27.27 kilo Newton. So this is where your problem ends. So this is the amount of live load required to balance this much amount of deflection due to the dead load as well as the pre-stress. So this is what is been asked in the problem. So thank you.